Which of the following is not equivalent to the prime factorization of 3600? The prime factorization tells us that any composite number can be uniquely written as a product of prime factors. Therefore, we can look at the prime factorization of 3600 by creating a factor tree. One way we could do this is recognize that 3600 is 36 times 100. Further breaking down 36 into its prime factors, 36 is 4 times 9, and 100 is 4 times 25. None of our numbers are prime yet, so we continue to break it down. 4 is 2 times 2, 9 is 3 times 3, 4 is again 2 times 2, and 25 is 5 times 5. Therefore, our prime factorization can be written as multiplying 2 together 4 times, or 2 to the 4th, times multiplying 3 together twice, or 3 squared, times 5 times 5, or 5 squared. We will now have to rewrite each one to determine which one is not and is equivalent to that prime factorization. One thing that we can do is we can recognize 2 squared is in its prime factorization, and so is 5 squared. So we will need to break apart 6 as 2 times 3. Therefore, we have number A equaling to 2 squared times a quantity of 2 times 3 squared times 5 squared. Taking each of our values and squaring it, we will get 2 squared times 2 squared times 3 squared times 5 squared, giving us 2 to the 4th times 3 squared times 5 squared, which is the same as the prime factorization of 3600. We will do the same thing for part B, noticing that we can break 10 squared into 2 times 5 squared. Therefore, we have 2 squared times 3 squared times 2 times 5 all squared. Simplifying this down, we will see that 2 times 5 all squared is the same as 2 squared times 5 squared, giving us 2 squared times 2 squared, or 2 to the 4th, times 3 squared times 5 squared. Part C, we would have to break apart the 15. We see that we have 2 to the 4th times 3 times 5 squared, and 3 times 5 all squared is the same as 3 squared times 5 squared, giving us 2 to the 4th times 3 squared times 5 squared, which is equivalent to the prime factorization of 3600. Looking at our last two, we see we have 12 squared times 5 squared, and we can break 12 apart into its prime factorization of 2 times 2 times 3, since 2 times 2 is 4, and 4 times 3 gives us 12. So we have 12 squared times 5 squared. 2 squared times 2 squared times 3 squared, that whole quantity squared, is the same as 2 squared times 2 squared times 3 squared times 5 squared, giving us 2 to the 4th times 3 squared times 5 squared, which is still equivalent to the prime factorization of 3600. Therefore, we can see that E must be our choice. Let's investigate it. We know that 4 squared is 2 times 2 all squared. 45 in its prime factorization is 9 times 5, or 3 times 3 times 5 all squared. Therefore, I have 2 squared times 2 squared times 3 squared times 3 squared times 5 squared, giving us 2 to the 4th times 3 to the 4th times 5 squared. Notice that our power on 3 are different, therefore E must not be the same as 3600.